with the Atlas telescope. And moreover, there is no cometary tail behind this object. In fact, the Hubble Space Telescope imaged it with the best angular resolution, and we see some glow in front of it, but nothing trailing it. And
just weeks ago, spacecraft orbiting Mars captured images that have left the scientific community stunned. The target? An interstellar visitor called 3I Atlas, a mysterious object that journeyed here from beyond the stars. But here's what has everyone talking. The new images reveal something no one expected. It's bigger, far bigger than scientists calculated. Bigger than Manhattan Island, possibly bigger than anything we've ever tracked from interstellar space. And that changes everything. Because an object this massive, moving this precisely, exhibiting these anomalies, shouldn't exist. Not naturally, at least. Tonight, we reveal what NASA and ESA scientists discovered when they turned their most powerful instruments toward this cosmic intruder. What they found challenges everything we thought we knew about visitors from other star systems. This is the story of 3I Atlas and why its true size is sending shockwaves through the astronomical community. July 1st, 2025. A telescope in the Chilean mountains detects something unusual. At first, it appears to be just another faint smudge moving across the star field. But within hours, astronomers realize they're looking at something extraordinary. The object is moving too fast. Its trajectory is wrong. And when they trace its path backward through space, the truth becomes undeniable. It came from outside our solar system. The discovery is announced to the world. 3I Atlas, the third confirmed interstellar object ever detected passing through our cosmic neighborhood. But unlike the previous two visitors, the mysterious Oumuamua in 2017 and Comet Borisov in 2019, this one is different. Very different. It's moving at 58 kilometers per second. That's 130,000 miles per hour, nearly twice the speed of the objects that came before it. And it's headed toward the inner solar system. The NASA-funded Atlas telescope network, designed to spot asteroids that might threaten Earth, has just spotted something far more intriguing, something that isn't from here. Within days, observatories around the globe swing their instruments toward 3I Atlas. Telescopes in Chile, Arizona, Hawaii. Amateur astronomers and professionals alike. Everyone wants a glimpse of the stranger passing through. And what they see raises immediate questions. The object shows a faint glow, a coma of gas and dust, the telltale signs of a comet coming to life as solar radiation heats its surface. But something about it doesn't look right. The trajectory is unusual, too aligned, too precise. And then comes the first major surprise. When scientists at Harvard University begin analyzing the data, they notice something that shouldn't be possible. The object is aligned with the plane of the planets, the ecliptic plane, to within just 5 degrees. The probability of this happening by random chance? 0.2%, less than 1 in 500. Imagine throwing a dart from a mile away and hitting a single window. That's the level of precision we're talking about. And it gets stranger. The timing of 3I Atlas's arrival is perfect. As it moves through the inner solar system, its path brings it close to Mars in early October, then Venus, then Jupiter in March 2026. These planets are constantly moving, yet 3I Atlas arrives at exactly the right moment to pass near all 3 of them. Coincidence? Perhaps. Or perhaps something else entirely. October 3rd, 2025. 18.6 million miles from Mars, something unprecedented is about to happen. The European Space Agency's Mars orbiters, Mars Express and the ExoMars Trace Gas Orbiter, have been repositioned. Their cameras, normally trained on the rust-colored surface of the red planet, are now pointing into deep space, waiting. These spacecraft were never designed for this. Their instruments are built to photograph a bright planetary surface just hundreds of kilometers below them, not a dim comet millions of miles away. Nick Thomas, principal investigator for one of the cameras, admits the challenge. This was a very challenging observation for the instrument. The comet is around 10,000 to 100,000 times fainter than our usual target. But they try anyway. Multiple 5-second exposures, stacked, enhanced, processed. And then, there it is. A fuzzy white blob against the darkness. Small, distant, but unmistakably real. The first close-range images of interstellar object 3I ATLS. But these images are more than just pretty pictures. They're measurements, data points, evidence, and they're about to reveal something that changes everything. Back on Earth, Professor Avi Loeb and his team at Harvard have been conducting their own investigation. They've compiled more than 4,000 observations of 3I ATLS from 227 different observatories around the world. They've tracked its motion across the sky with unprecedented precision, mapped every movement, every subtle shift in position. And they've been looking for something specific: non-gravitational acceleration. You see, comets don't just move under the influence of gravity. As they heat up near the sun, they release jets of gas and dust. This outgassing creates a recoil effect, like a rocket thruster firing. It pushes the comet slightly off its gravitational trajectory. We see this all the time with solar system comets. It's normal, expected. But when Loeb's team compares 3I ATLS's actual path to its predicted gravitational trajectory, they find something shocking. No difference whatsoever. Zero deviation. The object is moving on a pure gravitational path, as if the outgassing isn't affecting it at all. There's only one explanation for this. The object must be incredibly massive. So massive that the recoil from losing 150 kilograms of material every second has no measurable effect on its trajectory. Loeb runs the calculations. The mathematics are unforgiving. For the observed outgassing to produce no detectable acceleration, the nucleus of 3I ATLS must have a mass exceeding 33 billion tons. For a solid object with typical comet density, that means a diameter of at least 5 kilometers, 3 miles across, bigger than Manhattan Island from end to end. But it could be much larger. Based on other observations, possibly up to 46 kilometers in diameter. The implications sink in slowly. This isn't just unusual, it's unprecedented. Comet Borisov, the previous interstellar visitor from 2019, was estimated at around 500 meters across, a respectable size, but nothing extraordinary. 3I ATLS is 1,000 times more massive than Oumuamua. And Oumuamua, the first interstellar object we ever detected, was tiny by comparison, maybe 100 meters long. 3I ATLS is 1 million times more massive than Oumuamua. The question becomes inescapable. Why? Why would the third interstellar object to visit our solar system be so many orders of magnitude larger than the first two? Is this normal? Are massive interstellar comets common, and we've just been unlucky in our previous detections? Or is there something special about this particular object? Something that required it to be this large? July 21st, 2025. The Hubble Space Telescope locks onto 3I/Atlas. At 277 million miles from Earth, the comet is barely visible. But Hubble was built for this. Its instruments peer through the darkness and capture an image that will puzzle scientists for months to come. The image shows a teardrop-shaped cocoon of dust surrounding the nucleus, normal enough for a comet, but there's something else. An elongated feature, a jet of material extending from the nucleus, and it's pointing toward the sun. This shouldn't happen. Comet tails point away from the sun. That's basic astronomy. Radiation pressure from sunlight pushes dust particles backward, creating the classic tail we see in textbooks and photographs. But 3I/Atlas has an anti-tail, a jet extending toward the sun, not away from it. The measurements are precise. The jet is 10 times longer than it is wide. A narrow beam of scattered sunlight projected directly at our star. Behind the object, nothing. The glow is asymmetric, concentrated entirely in the sun-facing direction. No solar system comet has ever been observed with a structure like this. Avi Loeb and his colleague Eric Cato write a paper about it. They propose possible mechanisms, unusual ice sublimation patterns, asymmetric outgassing from surface features, but nothing quite fits. The jet remains unexplained. Then comes August 6, 2025. The James Webb Space Telescope, humanity's most advanced astronomical observatory, turns its infrared gaze toward 3I/Atlas. Webb's near-infrared spectrograph breaks down the light from the comet's coma into its component wavelengths. Each chemical compound leaves a unique signature, a fingerprint, in the spectrum. The data comes back. Scientists analyze it eagerly. And what they find contradicts everything they expected. The coma of 3I/Atlas is 87% carbon dioxide by mass, not water. Carbon dioxide. Water makes up only 4%. 4%. Carbon monoxide accounts for another 9%. This is completely backward. Solar system comets are water-rich, ice balls covered in a thin layer of dust and rock. When astronomers first spotted 3I/Atlas showing cometary activity, they immediately assumed it would be water-rich, like its solar system cousins. Papers were published claiming water detection. Scientists went on record predicting high water content. They were wrong. 3I/Atlas is a carbon dioxide comet, a type rarely seen in our solar system, and never before in an interstellar object. But the chemical anomalies don't stop there. Ground-based spectroscopy reveals something even stranger. The coma contains nickel, metallic nickel vaporized and glowing in the harsh sunlight. But here's the truly bizarre part. There's far more nickel than iron in the spectrum. This nickel-to-iron ratio is extremely unusual. A recent paper calls it unprecedented for natural comets. Where do we see this ratio in human experience? In industrial nickel alloy production. The chemical pathway to create nickel without iron is known as the carbonyl process. It's used in factories, in manufacturing, to create materials for aerospace and engineering applications. Could a natural process create this same signature? Possibly, but no one has demonstrated how. And there's another problem. At the surface temperature of 3I/Atlas, refractory minerals containing nickel shouldn't be vaporizing at all. Yet, there it is, glowing in the spectrum. Nickel without iron. A technosignature or an unexplained natural phenomenon? The debate rages. Then comes September 2025. 3i/Atlas does something else unexpected. It turns green. Astronomers notice the color change immediately. Greenish hues in comets usually come from diatomic carbon, C2 molecules fluorescing in sunlight. But spectroscopy shows very little C2 in the coma of 3i/Atlas. So why is it green? No one knows. Another anomaly to add to the growing list. And then comes the polarization data. When light scatters off particles in a comet's coma, it becomes polarized. The electric field of the light waves aligns in a preferred direction based on the geometry and composition of the scattering material. Astronomers measure this polarization to learn about the physical properties of cometary dust. For 3i/Atlas, the polarization is negative, minus 2.5%. This level of negative polarization has never been seen in a solar system comet. The polarization could be related to the unusual jet geometry, or to the composition of the dust, or to some other factor entirely. Again, no one has worked out the details. It's another piece of a puzzle that refuses to come together. But perhaps the most unsettling anomalies aren't physical at all. They're statistical. 3IA Atlas is aligned with the plane of the planets. We've established that. A 0.2% probability. But that's just the beginning. The object's arrival time is optimized to pass near Mars, Venus, and Jupiter, three major worlds all moving in their orbits at different speeds. Yet 3IA Atlas arrives at precisely the right moment to encounter all three within a span of months. What are the odds of that? And then there's the direction. When scientists trace 3IA Atlas's path backward through the galaxy, they find it originated from the direction of Sagittarius, near the Milky Way's galactic center, a region crowded with hundreds of billions of stars. But something catches Avi Loeb's attention as he examines the coordinates. The arrival direction of 3IA Atlas, traced back to August 1977, aligns within 9 degrees of a very specific spot in the sky, the source of the WOW signal. For those unfamiliar, the WOW signal was a powerful radio transmission detected on August 15, 1977 by Ohio State University's Big Ear radio telescope. It lasted 72 seconds. It was 30 times stronger than the background noise, and it came from deep space. The astronomer who discovered it in the data printout was so astonished that he circled it and wrote "Wow" in the margin. The signal has never been explained, never been detected again, and its source has never been identified. For nearly 50 years, it's been one of the greatest mysteries in the search for extraterrestrial intelligence. Now, Loeb calculates that if 3IA Atlas was at the location of the WOW signal in August 1977, it would have been about 600 times farther from Earth than the Sun, roughly 3 light days away. The power required to produce the WOW signal from that distance? About 1 gigawatt, the output of a typical nuclear reactor. The probability of this alignment being coincidental? 0.6%. Could 3IA Atlas have transmitted the WOW signal? Could it be carrying something that did? Or is this yet another cosmic coincidence in a growing list of improbabilities? Loeb has now identified 7 distinct anomalies associated with 3IA Atlas. The mass, far larger than previous interstellar objects. The jet, 10 times longer than wide, pointing at the sun. The chemistry, carbon dioxide dominant, not water. The nickel ratio, industrial-like, not natural. The green color, unexplained by composition. The polarization, negative, never seen before. The trajectory and timing, aligned and optimized. Each anomaly, taken individually, might have a natural explanation, but together they form a pattern that's difficult to ignore. Let's be clear about something. 3II Atlas could be entirely natural. A comet from another star system, a relic from the formation of exoplanets billions of years ago, ejected during the chaotic early days of its home system and left to drift through the galaxy for eons. The fact that it's unusual doesn't mean it's artificial. Nature is full of surprises. The universe is vast and strange, capable of producing phenomena we've never imagined. But here's what we know for certain. We're looking at an object the size of a small city. It originated from interstellar space. It's exhibiting multiple physical and chemical anomalies that have never been observed before. And it arrived in our solar system on a trajectory that seems almost deliberate. If we approach this question scientifically, setting aside prejudice and emotion, we must ask, what would we expect to see if this object were artificial? Maneuvers, course corrections, propulsion that isn't explained by outgassing. So far, we've detected none of that. The object follows a pure gravitational trajectory. But there's a catch. 3II Atlas is about to pass closest to the Sun on October 30th, 2025. If it's a technological object, that moment, perihelion, would be the optimal time for a gravitational assist maneuver. A spacecraft could use the Sun's gravity to alter its course dramatically while expending minimal energy. If 3II Atlas emerges from behind the Sun on a different trajectory than expected, the implications would be staggering. Financial markets would crash, one expert suggests, not because of immediate danger, but because of what it would mean. We are not alone. But there's another scenario to consider. What if 3II Atlas isn't a spacecraft itself, but a carrier? What if this massive object is a mothership designed to release smaller probes as it passes through the inner solar system? Think about it. The object's retrograde orbit, moving opposite to the direction the planets orbit the Sun, is actually ideal for deploying probes. The planets would come to the probes rather than the probes having to chase them down. It's an efficient strategy for reconnaissance. Avi Loeb has instructed his Galileo project team to monitor the sky carefully in the months after 3II Atlas passes the Sun, watching for any unusual objects, any anomalous activity, just in case. Here's what's important to understand. This isn't science fiction. This isn't speculation based on blurry photographs and wishful thinking. This is data. Over 4,000 observations from 227 independent observatories around the world. Images from the Hubble Space Telescope, spectroscopy from the James Webb Space Telescope, close-range observations from spacecraft at Mars. This is the most thoroughly documented interstellar object in history. And the data is publicly available. Anyone with a decent telescope can observe 3I/Atlas. Amateur astronomers are tracking it from their backyards. You can't hide this. You can't classify it. It's not a government secret or a military project. It's an object in space, visible to anyone who knows where to look. That's what makes this so compelling. The evidence is real. The anomalies are real. The questions are legitimate. What happens next depends on what we find. In November 2025, the ESA's JUICE spacecraft, currently on its way to Jupiter, will observe 3I/Atlas with multiple instruments, cameras, spectrometers, particle sensors. JUICE has a better vantage point than anything else we have. It's closer to the Sun, positioned to catch the comet in an active state. But there's a problem. JUICE is using its high-gain antenna right now as a heat shield. Data transmission is limited, and it's on the far side of the Sun from Earth. We won't receive the data from JUICE's observations until February 2026. That's months away. Until then, we wait. Meanwhile, 3I/Atlas continues its journey. It will pass Venus, then Jupiter, then exit our solar system forever, returning to the vast emptiness of interstellar space. We'll never get another chance to study it. This is a one-time opportunity, a cosmic visitor that arrived unannounced and will leave just as quickly. And we're doing our best to learn everything we can before it's gone. Step back for a moment. Consider what we're really talking about here. For all of human history, every generation that has ever lived, we've looked at the stars and wondered if we're alone. Are there other worlds, other civilizations, others like us, asking the same questions? For most of history, we had no way to answer. The distances were too vast, the technology too primitive. But now, in our lifetime, we have the tools to search. And interstellar objects like 3I/ATA represent a new frontier in that search. Instead of waiting billions of years to reach other star systems, we can study materials from those systems when they come to us. Every interstellar object is a time capsule, a sample from another region of the galaxy, carrying information about how planets form, how solar systems evolve, what chemistry exists in other star systems. Even if 3I/ATA is entirely natural, just a rock and ice from another star, it's scientifically invaluable. We should be sending missions to intercept objects like this, land on them, bring samples back to Earth. But we're not ready. We don't have interceptors waiting. We don't have the infrastructure. So when 3I/ATA leaves, it takes its secrets with it. And we're left with questions, observations, data that doesn't quite make sense. 7 anomalies, each one unexplained. Maybe they're natural phenomena we don't understand yet. New physics, new chemistry, new processes that don't occur in our solar system. Or maybe, just maybe, we're witnessing something else entirely. Something that challenges our understanding of our place in the universe. October 30th, 2025. Mark the date. That's when 3I/Atlas makes its closest approach to the Sun. That's when it will be most active, most visible, most studied. And that's when we'll learn if this object behaves like a comet of natural origin, erupting in a flare of outgassing, possibly fragmenting from thermal stress, or if it does something else, something unexpected. The spacecraft are watching, the telescopes are ready, the data will come, and then we'll know. Or at least, we'll know more than we do now, because that's how science works. One observation at a time, one data point at a time, building a picture of reality from fragments of evidence. 3I/Atlas has given us more questions than answers. A massive object, aligned trajectory, chemical anomalies, unexplained features, coincidences stacking upon coincidences until coincidence itself becomes improbable. We stand at the edge of a discovery, not the discovery we expected, not the one we planned for, but the one the universe has delivered to our doorstep. An interstellar visitor, bigger than expected, stranger than expected, challenging us to explain it, daring us to understand it, and forcing us to ask the question we've been avoiding. Are we witnessing a natural wonder? Or are we witnessing the passage of something far beyond human imagination? Soon, we will have our answer. If you're fascinated by mysteries from beyond our solar system, subscribe now. We're tracking 3I/Atlas every step of the way, and the biggest revelations are still to come. Hit the bell icon so you don't miss the follow-up. Now back to those shocking Mars images.